Okay, if mod of z minus 3i is less than or equal to 5, then the greatest value of z is, so say z is like a plus bi, then this would be a plus b minus 3i. The mod of that's less than or equal to 5, so that means a squared plus b minus 3 squared is less than or equal to 25. All right, so the greatest value of mod of z, so the greatest value of a squared plus b squared, square root of that, what's that value gonna be? So as you can see, this thing is more like something like the region bound by a circle. So if I try to graph this right on the xy plane, or maybe I should say the AB plane, I don't know. So this is the a axis, this is the b axis, so it's centered at 0 comma 3, so somewhere over there. Its radius is 5, so it's a circle like this, right? And we just want to find the biggest distance from this point to any point on the circle. Well, we know that's going to be the biggest distance, right? Yeah. Nice. So now what? So the greatest value of mod of z is, well, this distance is 5 and this distance is 3, so that's going to be 8. Okay, next question. The minimum mod of z satisfying mod of z plus 1 upon z equals to 2 is, all right. So the mod of that, that's kind of weird. Let us say this is like a plus bi. Maybe that's not a good way to do it. Maybe it is, I don't know. Think all of that should be equal to 2. All right, whatever, let's try it out. Say this is like a plus bi, and in fact, no, let's try it like this, r e to the I theta. Yeah, so say z is r e to the I theta, then this is going to be 1 upon r e to the I theta, all right, which is r squared e to the I times 2 theta plus 1 upon r e to the I theta, all right. So okay, that's kind of weird. We know that the magnitude of this denominator thing is just gonna be r, so that's one thing. What about this thing? This is like r squared cosine of 2 theta plus 1, okay, plus ir squared sine of 2 theta, something like that. So what's the magnitude of that thing? It's going to be square root of this thing squared, which is r power 4 cosine squared 2 theta plus 2r squared cosine 2 theta plus 1 plus this thing squared like r power 4 sine squared of 2 theta, which should be square root of r power 4 plus 2r squared c plus 1. Okay, this thing upon r, right? This is equal to 2. So we want the minimum z such that this will happen. So what's the minimum value of r so that this is going to happen? So now what? Well, r power 4 plus 2r squared c. Have I seen this somewhere? The discriminant of this guy, that's gonna be like 4c squared minus 4. Well, okay, so c squared minus 1 is like minus s squared, right? So it's always negative, which means this thing is always positive, by the way. So just square this, so it should be like square of that and that over there. So r squared plus 2c plus 1 upon r squared equal to 4r squared, I guess. Yeah, no, just 4. All right, so that means r squared plus 1 upon r squared equal to 4 minus 2c, okay. And we want the minimum value of this thing. We want the minimum value of r satisfying this thing. All right, so this should be true for at least one value of that. So first of all, what do we know? We know that r squared plus 1 upon r squared is less than or equal to, so what will be the maximum value of this guy? That will be 6 bigger than or equal to 2. Well, that looks correct. I mean, this thing is obvious because this is bigger than or equal to 2 using AMGM, so that means this is not useful, but it should be less than or equal to 6. Probably we can do something from there. Let's try. we want the minimum value, right? So yeah, let's just try it out. R power 4 minus 6r squared plus 1. Alright, what's the minimum value such that this will happen? It's gonna have two values. So say this has roots alpha comma beta, then r squared will be less than or equal to beta, which is the bigger root, and bigger than or equal to alpha, right? So the minimum value such that this thing happens, that will be when r squared equal to alpha, right? So okay, so r squared equal to minus b6 plus minus square root of b squared is 36 minus 4ac upon 2a. So yeah, which is 3 plus minus square root of this is supposed to be 9 minus 1, which is 8. Okay, so the smaller one is 3 minus square root of 8. So this is square root of 9, which means it's going to be positive, by the way. So r equal to square root of that I think will be the smaller one, right? So that means that's going to be the minimum value. And I mean, like, yeah, this is obviously true. Okay, cool. So bigger than 3 minus, alright, this is supposed to be 3 minus 2 square root 2. Cool, there it goes. Wait, but okay, this is also the same thing. This, yeah, whatever, both of them are correct. Next, if magnitude of z is bigger than or equal to 3, then the least value of z plus 1 upon z is, okay, well, we just calculated what this thing should be, right? Yeah, where is that? This thing. So what's the least value of this thing? That's what they're asking. Well, first of all, we know that this is supposed to be less than or equal to square root of r power 4 plus 2r squared plus 1 upon r, right? So when you do this with respect to the theta thing, so that's the maximum value. Wait, we want the least value, right? Okay, so this should be the other thing. Alright, which is, oh, this is nice. So it's gonna be r squared minus 1 squared, so square root of that, so just this guy upon r. And they also said that r is bigger than or equal to 3. Okay, this thing is just r minus 1 upon r, something like that. R is bigger than or equal to 3. Now what? Is this like increasing or decreasing, something like that? What's the derivative? The derivative is like 1 plus 1 upon r. Oh yeah, that's actually positive. That was weird. I mean, okay, this is in fact positive. So at least for r not equal to 0, this is defined and it's positive, which means, well, at 0 this is just not defined. Okay, and yeah, so as r approaches 0, this thing is going to approach negative infinity, so it's going to be really, really small. By small I mean I don't know how to say it, big, but in only in magnitude. In sign it's like really small, so it's gonna be something like this. Okay, when is it 0? At 1. So this is 1 where it is 0, and from there it just keeps on increasing. We are saying that r is bigger than or equal to 3, so at 3 you will have the minimum value of this function. So at 3 this will be 3 minus 1 upon 3, which is 9 minus 1 upon 3, which is 8 upon 3. Yes. Next question. If magnitude of z minus 3 plus 2i is 4, then the difference of greatest and least values of, right, that's kind of weird. It's not that bad. So the magnitude of this thing is 4. It's like, say this was x plus iy, so this would be x minus 3 plus y plus 2 iota. Magnitude of that is 4. That means x minus 3 squared plus y plus 2 squared equal to 4 squared. Right, so this is a circle with the center on 3 comma minus 2 and radius 4. So if I graph this 3 comma minus 2 somewhere over here, radius 4, what's this distance? Like square root of something. Square root of 9 plus 4 is 13. It's less than square root of 16 for sure, which means it's gonna be something like this. Okay, so the difference of the greatest and least value of z. Okay, this is the what's happening? Okay, so either this is the thing or this is the thing. No, yeah, this is going to be the thing. So if you talk about a diameter passing from this thing, right, so this length will be the smallest and his complete length will be the greatest. So the sum, we know what the sum is, but we don't know what the difference is, right? Well, whatever, we do know what this distance is. This distance is just square root of 9 plus 4 13. Okay, I'm getting a bad feeling from this. And this thing is 4, this thing is 4 minus square root of 13, so it's going to be 4 plus square root of 13 minus of 4 minus square root of 13, which is 2 square root of 13. Okay, fine. Next, if center of a regular hexagon is at origin and one of the vertex on Argand diagram is 1 plus 2i. So center is at origin, 1 plus 2i somewhere over there. That's one of the vertices. Then it's, come on. Okay, so this distance which is square root of 5, right? So we know that it's like the distance from the center to vertices is square root of 5. That's the same distance as the side itself for a regular hexagon, right? So this distance is the same thing as that distance. So that means it's just going to be 6 into square root of 5. Yeah, it was easy. Complex number z1, z2, z3 satisfying z1 minus z3 upon z2 minus z3 equal to 1 minus iota square root of 3 upon 2 are the vertices of a triangle, which is... Okay, that's kind of weird. Okay, this is not nice. Z3. Now if I think about it, it's not that bad. Come on, think about it. We got everything in terms of z3, right? So z1 minus z3, that's the coordinate of the point 1 with respect to 3. It should be this weird vector, right? So I'm gonna view it as a vector. Wait, no, not as a vector. For now it's just a complex number times z2 minus z3. Okay, so yeah, this looks correct. What do we know? Just multiplying by this thing, right? That's gonna change the complex number by rotating it. Okay, so first of all, this thing is like e power I. So cosine is 1 by 2, sine is negative square root 3 by 2. That's supposed to be negative 60 degrees. So minus sine of pi by 3. Okay, and z2 minus z3. So now it looks much better, because so with respect to z3, so this would be this is not the origin, this is z3. Say this point is z3, you got z1 minus z3 as some vector like that. Okay, you got z2 minus z3 as some vector like that, right? So this is z2, and you're going to multiply this by this thing, e to the power of minus I sine of pi by 3. So what that does is that it will rotate this vector 60 degree anti-clockwise, wait, no, clockwise, because minus, and that will in fact bring it over here. So yeah, this definitely looks correct. I mean, like, this angle is 60 degrees. Okay, moreover, these two must be equal in length, otherwise it won't work, right? So what that means is, yeah, it's actually an equilateral triangle, because just look at this is z3, this is z what is this, z1, no, this is z2, this is z1. So multiply that, yeah, correct. So just think about it, these two are equal, this angle is 60 degree, definitely just an equilateral triangle. Of area 0, well, no, the points given by z1, z2, z3 in the complex plane are the vertices of a parallelogram taken in order if and only if. This is weird. Are the vertices of a parallelogram taken in alternation only. All right, it's not bad. It's not bad. So z 4, z3, z2, z1. What do we know? Z4 minus z1, that will be this vector. So z4 minus, this vector. Z4 minus z1, this should be equal to this vector, right? Z3 minus z2. So if that's correct, that these vectors are, yeah, that basically means you got these two parallel lines and these have the same length. That in fact ensures that it is going to be a parallelogram. Yeah, so correct, which means z4 plus z2 equal to z1 plus z3. And I guess I can similarly say for these as well. So like z4 minus z3 equal to z1 minus z2. Well, no, this is the same thing as that. So yeah, this will be our thing. So z1 plus z3 equals to z2 plus z4. Right, next question. In complex plane, z1, z2, z3 represent the vertices ABC respectively of an isosceles triangle ABC, of which, okay, that's an isosceles triangle. Angle C is a right angle. First of all, draw it. Angle C is a right angle. Then the correct statement is, okay, vertices ABC of an isosceles triangle ABC. So these are going to be AB. Okay, these are equal most likely because this is going to be the biggest side. It cannot be equal to any of these. So these are equal. What does that mean? That this vector is like r e to the power of I theta. Well, no, yeah, correct. That represents a vector as well. So the difference of the position vectors, that's going to be this vector, and this vector is going to be r e power pi by, okay, I theta minus pi by 2, or maybe this thing is theta and this thing is pi by 2 plus theta. Well, that makes sense. This is going to be theta plus pi by 2. All right, that's nice. So what can we do with that? Yeah, we can divide that. So say this thing is like z. Okay, A is represented by z1, B is by z2, and this is by z3. Okay, this quantity, when we divide this, is going to be e power I pi by 2. What's that? So cosine of pi by 2 0, sine of pi by 2 1, so it's going to be 1. Sorry, it's going to be I. Nice. Yeah, that looks correct. Okay, now what? But that's not all. Okay, now what do we do? So got z1 minus z3, z2 minus z3. Is there anything which is remaining? Yeah, z1 minus z2, which will be this vector. Alright, what can we say about this vector? You do not have magnitudes right now, so that will be pretty incorrect if we say something like that. What do we know about this vector? Well, really, we know almost nothing. We know this is correct. What else do we know? Oh yeah, this is also isosceles, by the way. So you will have z1 minus, its magnitudes, but okay, this is isosceles, and that's why this r thing is same. So that got figured out correctly. So yeah, no big deal with that thing. This does look correct. It is gonna be something like complex number diagram. Yeah, it looks correct. But is that in the options? No, it's not. That's not good. Z1 squared plus z2 squared. Okay. One thing. What if I take this as things like that vector and that vector? It's still not gonna work, right? I know, it's just not going to work. So what, which of them is even correct? Z3 minus Z1, Z3 minus Z2 squaring that thing. No, that ain't nice. It should be something like this: Z1 minus Z3 squared equals to negative of Z2 minus Z3 squared, right? That's not the thing. I don't know. Move on. Center of a regular polygon of n sides is located at the origin, and one of its vertex Z1 is known. The vertex adjacent to Z1 is equal to. Okay, the center of a regular polygon of n sides. I don't know. I'm not going to draw this. Is located at the origin, and one of its vertex is known. The vertex adjacent to n1 is equal to. So the vector it should just be rotated by some angle. We know what that angle is. It's going to be 2 pi by n. So that will give us this vector, which is representing the other thing, right? The adjacent position. Right, so it's going to be z1 e to the power of iota 2 pi by n. I mean, not bad. Not bad, so it should be this thing. It can also be negative. Well, okay, it did give plus minus because there are going to be two adjacent vertices, right? Okay, next question. If magnitude of z equals to 1 by 2. Okay, magnitude of z is 1 by 2. Z1 is given, and Z1, Z2, Z3 are in anti-clockwise sense. Okay, first of all, let's draw this. Z1, Z2, Z3 are in anti-clockwise sense. Then Z2 is. We know what Z1 is, alright? We know the magnitude of Z as well. So we can write an expression for Z in terms of, yeah, that will work, but we don't know what Z3 is. Then Z2 is, wait, what is this thing? Magnitude of Z, which Z? There are three of them. Oh, so circumscribing the circle. Okay, so this is an equilateral triangle which is circumscribing this. Right, okay, fine. So this is the circle that it is circumscribing, which means this is the in circle, okay, which has radius 1 by 2. Okay, if Z1 is given, and Z1, Z2, Z3 are in anti-clockwise sense, alright, then Z2 is, come on, it's not bad because you just gotta multiply this by the 120 degree thing, because they did give us it's an equilateral triangle, so no big deal, right? Well, yeah, looks correct. This is supposed to be 1 by 2, and this is supposed to be what? It's just 1, which, yeah, it looks correct because it's supposed to be 60 degrees and stuff. So yeah, which means you just got to multiply by e to the power of I 120 degrees, and that will give us Z2. So Z1 is this thing, so like e power I, this is pi by 3, alright, that times, so just move 120 degrees one more, so it's going to be 180 degrees in that case. That would be pi, so e to the power of I pi. I have seen this somewhere. Yeah, I have seen this somewhere. Cosine is -1 and sine is 0, so it's going to be -1. Easy. It's the identity, it's Euler's identity, right? This was too easy, and we did not even use this information that they gave us what this length is and stuff. No, just straight away multiplied by that. What question even was that? Okay, z equals to x plus y iota, then area of triangle whose vertices are points z, iz, and z plus iz is. Okay, area of the triangle whose vertices are, right there in Cartesian coordinates. So z is x, y, other coordinates are, so multiplying this by I, I'm gonna get -y comma x is the thing. Okay, z plus iz, Just multiply these two. Sorry, add these two. So it's gonna be x minus I. Hey, I've seen this. These are actually just two of them, and then this is. Huh. So this is z. This is z plus iz. Right. So see, these are the vectors, and now z plus iz will be something like this, and you wanna say the area of this triangle. Yeah, I've definitely seen this somewhere. It's basically a parallelogram, but we almost know nothing about it at this point. This is not just a parallelogram, it's in fact a rhombus, because these two are going to be the same. So we just need to find what the diagonals are in length, and we will be done. But okay, that's not possible because we have just given the area and stuff. So we at least know this is r, where r is the magnitude of z. So yeah, and z plus iz, well, I, that is e to the I pi equals to, no, the I pi by 2 equals to iota. So that means this is gonna be 90 degrees in fact. Okay, that's really nice, which means something like this, huh? So this will be z, this will be iz, this is z plus iz, and they want us to find the area of this triangle. Not bad. This is r, this is r. This is gonna be half of r squared. And what's r? R is just magnitude of z. Yeah, easy as that. Yep, next question. The locus of the point z will satisfy the condition argument of z minus 1 upon z plus 1 equals to pi by 3 is. Okay. So, well, okay, whatever. Z minus 1 upon z plus 1. I have seen this somewhere, it feels like that. Okay, whatever. What we can say is like z minus 1 upon z plus 1 equals to some constant times e to the power of I times pi by 3, which is, okay, so cosine of 60 degrees is 1 by 2 plus square root of 3 by 2 iota. Okay, cool. And when is this going to be true? Okay, fine. So this does not matter. So what matters is like argument of this thing minus argument of that thing, that should be equal to this. Not nice, not nice. Okay, whatever, let's just solve this. So it should be z minus 1 equals to r e to the I pi by 3 z plus r e to the I pi by 3. Okay, now what? Now just put that over there. It should be 1 plus r times, maybe we should first of all like, no, let it be 1 plus r e to the, does it look so weird? Maybe that's not how it's supposed to be. Yeah, it does feel like that, but come on, whatever, let's just do this. To the I pi by 3, that's just going to be this thing, 1 by 2 plus square root of 3 by 2 I upon, so it should be minus r by 2. Now we need to rationalize this and then put x and y over there and stuff, so it's going to be pretty complicated. Should we do this? So we have straight line, a circle, a parabola. Well, we'll never know unless we find out. So let's do this. Okay, so 1 plus r by 2 plus square root of 3 by 2 r, right? Yeah, iota, all of that times the conjugate of this guy, which I wish these conjugates were not like these were like, but no, that's not the case, so just got multiplied like that. So 1 minus r by 2. Isn't there some easy way to do this? Why is this so complicated? It's the square of this guy. Okay, this is not looking nice. First of all, write it like this: 2 plus r square root 3r iota upon 2 minus r minus square root of 3r iota, and then multiplies by the conjugate, so it should be 2 minus r plus square root of 3r iota, and square these. Should be plus, that iota is gone, it's just the square of this guy. Okay, let's do it. So this times that is going to be 4 minus r squared. Okay, this times that's going to be 3r squared, but in negative, so minus 3r squared. Okay, that's all the real parts. What about the imaginary parts? So it's going to be square root of 3 plus square root of 3r into, so 2 plus r plus 2 minus r is just 4 iota. Okay, upon what's this? Yeah, just 4 minus, okay, just some constant, something like that. Right, let's do this in that case. So 4 minus 4r plus r squared plus 3r squared. This should be just that. Isn't there any way to do this? So now we gotta eliminate r somehow. Wow, that is not nice. First of all, simplify this: 4 minus 4r squared plus 4 square root 3r iota upon 4 minus 4r plus 4r squared. Okay, that's nice, it's simplifiable. So 1 minus r squared plus square root of 3r iota upon 1 minus r plus r squared. Alright, it's weird. So now what? So we know x is going to be equal to 1 minus r squared upon 1 plus r squared minus r. Y is going to be square root of 3r upon 1 plus r squared minus r. Now what do we do with this? So now we need to eliminate this somehow, but how? That's the question. Okay, this goes over there. Maybe it's not that bad after all. This is gonna go over there, square root of 3. Okay, so if this was 1 plus r squared, it would have been really easy, but it's not. So now you need to think of something else. So y squared by 3, that's going to be r squared. No, but that will have that square over there as well. That's not nice. So then what do we do? It's going to be 1 minus r and 1 plus r, and that's not going to work. Don't think. Is there no other way? There must be, right? Do we really have to solve this? Oh, okay, that's not nice. What about we divide this by r? So that will be like r minus 1 upon r upon r plus 1 upon r minus 1. Not bad. Hey, first of all, just multiply this by something like say plus 1. So this will be x plus 1 equals to, so if you multiply by that, so write 2 minus r upon 1 plus r squared. Wait, not bad, not by. Okay, not bad. So y by square root 3 is r upon 1 plus r squared minus r. Just maybe we can try to solve this. So we really want plus r squared over there, right? So just multiply by 1. So add 1 once again, so it's going to be x plus 2 is in fact r squared minus 2r plus 3, yeah, upon r squared minus r plus 1. Okay, so we got that r squared. Now we need to take care of this thing. How? Okay, we don't want that 1 and stuff though. Just if we could, like, okay, so x plus 1, we can use that somehow to kill away these extra things. So we can definitely kill away this constants. Yeah, so we're gonna subtract that. Wait, that will just kill away everything. That's not nice. That's just not nice. So you cannot subtract that. So then what? Oh no, it's gonna be r squared plus 1 over there. It's gonna be 1 minus r squared over there. Adding them, gonna get something like that. Hey, so yeah, adding them, Not bad, huh? Still, it's just too much of a stretch to do it like this, because there should be some other way to do this, right? Limit of z minus 1 upon z plus 1. Huh. Well, so that argument is this guy. What that means is that the argument of, well, negative, okay, so if we just multiply by negative 1, negative 1 is like e to the I pi, that means we will just be rotating by 180 degrees. But good thing we are doing this for both of them, which means this is the same thing as argument of 1 minus z upon minus 1 minus z equal to pi by 3. So say like z is some number, and then 1 and minus 1, these are two numbers, like, okay, those two vectors, the angle between those two vectors, that's pi by 3. That's what we are talking about. All right, so fine. So say you got this thing, you got, okay, this is not that bad, not that bad. Yeah, whatever, it's gonna be the same thing. So looks like we just cannot solve it like this will take forever, so gonna do something else. Got 1 and minus 1 over there, so your z is somewhere over here, the angle between these two, right, that's going to be pi by 3. Huh, why does this look like a circle? Yeah, it really does. I think it is in fact a circle. Okay, so x, okay, so x minus 1 and x plus 1, these are not diameters. Yeah, and it's pi by 3 is the thing. So at the center it's going to be 2 pi by 3, so it's going to be like 120 degrees over there, 120 degrees. And these are minus 1, it's like this distance is just 2. What's this distance gonna be? This is only 60 degrees. So yeah, cot of that's like 2 by square root 3. Wow, that's not nice. 2 by square root 3, huh? So this center, this will be something like 0 comma 2 by square root 3. So it's gonna be like x minus, okay, x squared, just x squared, plus y minus 2 by square root 3 squared equal to the radius. The radius is whatever the heck that radius is. So minus 2 square root 3, how do we even get that? Y minus 2 upon square root 3. Well, we already got y square root of 3 r minus all the stuff. And now what you're saying is we want y minus 2 square root. So okay, so y minus 2 square root of 3. What's that going to be? That's going to be, if we do that, it's going to be square root of 3 into r minus 2 upon 1 plus r square minus r. All right, you're saying the square of that, so that will be 3 into the square of this guy plus x squared. It doesn't look good though, and this should be equal to the radius and stuff. Okay, I don't think it should be like a circle, or should it be? I mean, a circle definitely does actually have this character, but is it really just a circle, or it can be more things? I don't know, right? Well, if this angle is fixed, okay, what do we know? We know that, yeah, this side is fixed, this angle is fixed. Then what? Come on, think. You don't know anything about these angles. These can be anything. Can you actually figure out what this radius should be from a particular point? Well, not quite. Can be. I mean, sure, like all of those do show this property. What if your angle is like slightly bigger than that? It will be a different circle altogether. It's gonna lie on that circle in that case. Yeah, I mean, no, but any center that has 120 degree, that will be doing it. But okay, so any center, that would essentially mean that it has the midpoint, which doesn't make sense. So it's going to be always on this guy. So it's either you got this over here or over here. both of them will work. No, one of them won't work. So it should be something like a circle, huh? Okay, 1 minus 2 square of that, so it's going to be like 3 into r squared minus 4r plus 4 plus x squared, so it should be like 1 minus 4r squared plus r power 4 upon the square of this guy, so like r squared minus r plus 1 squared. Right, so this would be like r power 4 3r squared minus r squared just minus r squared minus 12r plus 12 plus 1 is 13. how does this even add up? 13, so it's like 13 over there and this goes over there. Okay, so it should be r power 4. You got missing r cube over there, right? So this r is gonna go over there, this is gonna go there. 13, huh? Can this be factorized? Well, sure, it can be factorized, because maybe not. Maybe it cannot be. It's 1 minus 4. Wait a second. How did we get 4r squared and r power 4 over there? It was x. Okay, it's supposed to be 2r squared. Was sorry. So 2r squared and 3r squared. That would be positive r squared. So this would be plus over there, right? So now, is this factorizable into r squared minus r plus 1 and something else? And how? I don't know. This is not working. Okay, whatever. I'm leaving this. It really does look like it will be a circle, but whatever. Next question. If mod of z squared minus 1 equal to mod of z squared plus 1, then z lies on z squared, it multiplies by the argument by 2 and the radius is like that. Fine. Okay, minus, well, maybe like r squared e to the power of 2i theta minus 1. This thing is equal to mod of z, so it's like r squared plus 1. Okay, fine. Then what? Then z lies on. So the mod of this guy, this is like r squared cosine of 2 theta minus 1 plus I r squared sine of 2 theta. The mod of this guy, well, that should be equal to square root of r power 4 c squared plus 2i sorry, yeah, that's this squared, so it's going to be minus 2r squared c plus 1 plus r power 4 s squared. This thing is just r power 4, right? So square root of that is equals to this, so just square that's like r power 4 minus 2 r squared c plus 1. The square of this guy, which is r power 4 plus 2 r squared plus 1, well, this cancels. Nice. So just have this thing, so r squared cancels as well, 2 cancels, just got minus c equal to 1, c equals to minus 1. Okay, this can only happen when your, okay, that's weird. So cosine of 2 theta equals to minus 1. Yeah, that doesn't look very nice. So 2 cosine squared theta minus 1 equals to minus 1, it cancels, just get cosine theta equals to 0. Cosine theta equals to 0. Wow, okay. The I theta term is like either I or it's 0 or something like that, which basically means it's going to be a line. Yeah, it's just a line. It's a straight line, huh? Okay, next question. If z1, z2, z3 are the vertices of an equilateral triangle with p of 1 plus I as its circumcenter, then okay, p, which is 1 plus I, so this is their circumcenter. Fine. Then z1 squared plus z2 squared plus z3 squared equals to, okay, have we seen this somewhere? Z1 squared plus z2 squared. Oh god, what is this? You know, it's like their radius is gonna become double and their angles are gonna become 2 times. Okay, How does this even help? S of an equilateral triangle, you say. This is their circumcenter. It's gonna be like z1 minus p and stuff. God. There must be some kind of property that I don't know. Should we just do something like a special case and that will help us do it? How? Well, maybe we can use something like algebra. So z1 squared. Come on, think. This is not like that. Then z1 plus z plus z3 upon 3. Well, that's going to be the centroid of the thing, right? Yeah, centroid. Well, that's the same thing as the center itself. So well, that's gonna be p. So we know that p is just z1 plus z2 plus z3 upon 3. Okay, so this is gonna be 3p over there. Now let's try to square this. So it's like z1 squared plus z2 squared plus z3 squared. It's not such a good idea though. It's not a good idea. Yeah, but what else can we even do about this? It's gonna be plus 2z1 and stuff. Okay. What if it was like z1 plus 1, something like that, squared minus p squared? It's like p squared over there. z1 z2 z3. No, that's not. How do we gonna do this? z1 z2. Do we know anything about them? No, we don't. We know that z1 and z2. So yeah, the multiplication part, actually division of that's going to be some particular argument. Yeah, but that's not really useful, is it? How can I even solve this? Like square that and then that will do this thing, and 2z1 z2. What I'm gonna do with that as well? So no way, right? That's not gonna work. Or will it? Well, either I'm gonna get it back to whatever we started with, or it's just not gonna work. Well, z1 plus z2 plus z3. What can we do? Take that over there and then square it? No, that's just straight up not good. Square of that, come on, why is this not working? So it's z1 minus p squared. That will be z1 squared minus 2z1p plus p squared. Maybe it will work. What are your feeling of that? Okay, so this thing squared plus z2 minus p. Okay, those are these vectors. Well, okay, so the sum of those vectors is going to be 0. But what do we do when we square them? When we square them, we increase the angle by 2. So the argument of whatever this thing is, that will be increased by 2, and its length will also be increased by 2. But yeah, that means that the difference between these, the difference between them will also be increased by 2. So instead of having pi by 3 now, they will be having 2 pi by 3, which means they're gonna 2 pi by 3. No, sorry, 4 pi by 3. So this and then that directly over there. And then once again, it's like this is gonna be 2 pi by 3, and then hey, but that still is just some kind of equilateral triangle. So they are still an equilateral triangle, but now instead of having z1 over there and z2 over there, it will be having z2 over here and z3 over there. Okay, so they are still an equilateral triangle, but not as we expect them to be. Okay, fine. So this thing squared, what are we doing by adding them? Yeah, it's just, which is gonna be like, okay, this is 2z1 over there, 2z2, no sorry, dash. Okay, that's nice. These are also at the same time in an equilateral triangle, which means, and these are actually just these numbers, right? So their addition, that has to be, so their mean is also just p, so that means their addition is 3p. Wow, that's nice. That is really nice. So zi minus p squared, summation of that, zi squared minus 2zi p plus p squared. We know that summation is just going to be 3p. Easy as that, huh? That's nice. But in this case, like p is 0 because we have shifted this, so that's just going to be 0 in that case, right? So this is just 0. Wow. I mean, really, wow. And yeah, these are complex numbers, so we cannot use that kind of trick, but okay, fine. So this thing, summation of that, and then 3p squared, this should be equal to 0. Okay, that's nice. Now what? Well, so just got summation of zi squared equal to 2 times the summation of zi p minus 3p squared. So this is like 2p summation of zi. We know what this is. It's just going to be 3p. So 2p times 3p minus 3p squared. So just 6p squared minus 3p squared, which is 3p squared. Huh. That's nice. So in this case, it's just going to be 3 times the square of this thing. So it's going to be 1 squared plus iota squared is like minus 1 plus 2 iota. So it's going to be 6 iota. That was nice. Hey, have you seen a similar kind of question somewhere with squares and things? Yeah. Of an isosceles. Wait, isosceles triangle. That's not what he wanted. Huh. Well, okay. Isosceles triangle. No, that's not what we want. Yeah, whatever. I think there are a lot of these properties which I don't know, so I need to study them first. Maybe then I'll be able to solve this. Anyway, so last question. Z1 is this thing, Z2 is this thing, then the projection of Z1 on Z2 is what? Projection. It's like in terms of vectors, the projection. So how much is it along that and things like that, right? Right, so think about it in terms of vectors itself. So it's going to be 2i hat plus 5j hat. That's the first vector. The other vector is 3i hat minus j hat. So their projection, for that we need to find the dot product. So that's going to be 6 minus 5, that's the dot product, upon the magnitude. Yeah, so that will be like the projection times multiplication. So the magnitude of whichever vector we don't care about on z2, so it should be z2. So the magnitude of this vector, which is just square root of 9 plus square root of 10. Alright, so this should be 1 upon square root 10. That's one of the projection. Easy. So this was easy. Okay, let's check. Okay, 15th B, 14th A. How? Circumcenter. I don't know. So 14th is incorrect. Whatever. 13th B, 12th. Okay, I knew it. It should be a circle, but we didn't have the means to prove it yet, because there must be something else that we don't know. Right. 11th. What? Z, just Z square. Okay. The area of a triangle. Z. What is this? Okay, Z is something. We don't care what that thing is. Whose vertices are points Z, I, Z, and Z plus I, Z. So this is Z. Multiply by I, that will give us 90-degree rotation. So it's going to be I, Z over there. Adding them is just like adding vectors. So this is something like this. Okay, we know these are just the radii. So these are the same length. So yeah, it's going to be square. And we want the area of the triangle whose vertices are this, this, and this. So it's going to be this thing, right? Am I doing something wrong? No, it does look correct at least. So half of r into r. Yeah, that should be the thing. What's going wrong? It should be z squared upon 2. I don't know. It's given incorrect though. Okay, 10th D. Okay, fine. 9th A. 8th D. Whatever. 7th B. 6th B. What? Right angle isosceles? What? I'm thinking that maybe the answer key is not very correct. The complex number satisfying this relation, it's gonna be like R e power. Yeah, this is just, it's having R equals to 0, which means that these vectors were of the same length. Alright. So yeah, but this is definitely not that. Okay, let's go sine of 60 degrees and then yeah, it's negative 60 degrees that we're talking about, so it should be e to the negative I pi by 3, which means that yes, it's just an equilateral triangle. So why is this supposed to be right angle obtuse or anything? Sixth, but they did give us B. Well, that's not correct, right? How is this supposed to be right angled isosceles? No, something is wrong with this answer key. Okay, whatever. Fifth, D. Okay, fine. Fourth, A. Third, C. Second, right? I mean, like both are correct, but they're the same thing. First, A. Right. So, whatever. See you in the next video.